Now then, this video is just a few clips put together. Yeah, I've chopped a lot of footage out. Yeah, but I was messing around in the workshop, experimenting with the Dyson batteries, just trying to make some sense out of it. I saw a video by a Japanese guy, and he was showing putting a magnet to part of the BMS. So I thought we'd have a go at that, and then also have a go at backwoods methods of getting this cleaner vacuum to work, just really rough and ready. So I just thought I'd have a go, and then halfway through I thought, do you know what, I better just get the camera out and capture this. So here you go, make of it what you will. Right, I was doing a bit of research, and apparently that there is a magnetic switch. Apparently not. Ah, right, that's interesting. Okay, we put a magnet there and there's a blue light. I don't know what that blue light means, but there's a blue light. So there was this, I think he was a Japanese guy, but it was all in subtitles, and it was not what you would call brilliantly can't remember what the word is now. Anyway, it changed into English. Yeah. So we have a magnet, and that makes that blue light come on. Take the magnet away, and let's put the charger involved. We've got a charger somewhere. Switch that on. Ah, okay. So I've just plugged the charger in, and the blue light's on. So that's to do with charging somehow. I thought we got it cracked, but obviously not. We've still got nothing on that output there. This is 24 volts here, so it's a good battery pack. Okay, so we'll unplug that. Now, I'm wondering, just pull up a seat. I'm just wondering what voltage we have going to that micro switch, and whether it'll be against positive or negative. So let's try there to there. Nothing. Ah, did we get something? It's intermittent. I've just dropped everything on the floor. Right, so I'm just wondering, we've got that on the positive. What voltage we have at that micro switch. So nothing relative to positive. We've got 24 volts there. Interesting. So okay, so I just operated that micro switch. So that side is effectively the positive against negative. So if we took that wire there, or we took a wire from there, okay, and we brought it out of the case, and we soldered a wire to there, and we brought that out, then we could get that to operate a relay. So we would go from there, yeah, which is that's the switch side, is that right? So when it is depressed, it's on. That's 24 volts, that's 24 volts. But when that micro switch is operated, this one switches off. So we come from there to a coil of a relay and back to there. And then the contacts from that relay go across there. Now, one of those, that one, we've already got positive there, so we only want to switch the negative, so we go from there to the relay and back to there. Interesting. Right, so this magnetic thing is all to do with charging, it's nothing to do with that. Yeah, so it seems. So we put a magnet there, and that comes on. Ah, hello? Okay, that sent me down a rabbit hole. This whole business of magnets and what seems a bit sensitive, and now that battery is flashing and we haven't got that voltage anymore. So I think it's all a bit weird. Let's just and now it's flashing again. See, this battery's got the right voltage between there and negative is 24 volts, right? And we've got 6 cells, so 4 6s are 24, so they're fully charged. But this BMS, now we've got the light on because we've got the charger involved. I don't know whether you can see that light or not. Okay, so we'll just give it a few seconds of boosting charge. Right, have we got a voltage there? Not really, a ghost voltage. Put the magnet on there and we got 24.2 volts, and then it goes down to nothing. 24 volts. Okay, I did try the vacuum on there. I'm just wondering, you know, how many of these get scrapped because the contacts are a bit mucky. Let's stick the charger back on there. Well, the contacts look clean enough, but we'll just ignore all the niceties and just plug it in, at which point it should go, but it doesn't. Right, because the micro switch is not depressed, so magnet on there, 24 volts. Okay, stick that in there. Right, I think that was a useful experiment, but mostly pointless. There's something in here that switches the power off, even with the help of a magnet. So, going back to basic principles, let's just zoom down. So we take a wire from there and we bring it out through the case, and we take a wire from there, bring it out through the case. That wire can be fairly beefy because that will not only be the return on the relay, but it will be the power cable to the contacts, which then goes back to there. Yeah. Okay, so we need to test this in principle by wiring between there and there. Yeah, does that make sense? Right, let's give it a go. I'll just get the soldering iron out, and I'm just going to solder to the edge of there and solder there, bring some wires out. Okay, I've got those two wires soldered on there. Yep, get rid of that bit of solder. Now, theoretically, let's just remove that spring for safekeeping over there. Theoretically, yeah, if I put that in there, okay, and touch these two together, that motor should run. Okay, so where would we put a relay? Probably here, or on the side, or somewhere, or up here. So it's 24 volts. We could use a 12 volt relay with a resistor. How big does it need to be? How much current is this motor drawing? That's the next thing to think about. And there we've got an analog meter. Okay, wrong way round. Wow, that's a lot of current. Okay, let's just go and get, that's 20 amps. Let's go and get the clamp meter. Okay, here's the DC, 0 out. Okay, stick that on there. How much current does this thing draw? $20 amps. 20 amps at 24 volts is half a kilowatt. So that'd have to be, of course it is, yeah, so therefore your relay would have to be fairly beefy if you're going to go down that route, but still there is no control on discharge, yeah, so you're going to have to be careful, but it will get you out of trouble. Anyway, sort of interesting. You'll have to fiddle around with relays. If you're going to use a 12 volt relay, which means it's got a 12 volt coil in it, then you'll have to put a resistor in series. But otherwise you could just put a switch on that. That's even easier. Just put a switch there, forget about all this extra nonsense, just have a switch there, switch it on, use it, switch it off. That's better, isn't it? But fairly beefy switch again, 20 amps. Right, let's hear some comments, and this is just real experimenting in the really rawest state. So, rawest meaning of the word. Okay, catch up with you soon. Bye for now. 20 amps.